Hello, everyone. Welcome back to this class. Remember, I told you in class that we were going to do a multiplication division algorithm because we didn't have much time to do it in class. So please, let's go through. I am not able to write on this screen, so I'm going to type. I hope it comes out well. So the multiplication we are doing is 1.5 to the base 10 times negative 0.4375 to the base 10. Right from the beginning, I know it's going to be a negative answer, but let's see how it's going to go. So you start by converting these numbers to the normalized form. So 1.5 to the base 10. How I see it is that I see 1 plus 0.5. That's what 1.5 is. And the binary for 1, let me give. The binary for 1 is literally 0, 1 or 1, right? The binary for 1 is 0, 1. But what is the binary for 0.5? To get the binary for 0.5, we're going to multiply 0.5 by 2. So it's going to be, let me put it here, 0.5, 0.5 is 2, which the answer is 1.0. And we're going to keep the value to the left of our point. This is going to be part of our multiplication, our conversion. The next thing is that we're going to take the 0 point, everything after the decimal, after the point, and do the same multiplication. It's 0, so it's going to end up with 0, 0. This is 0.0 times 2 is 0. So in fact, as soon as you get 0 at the end here, you know you're done. So our binary representation for this is literally 0, 0, 1.1, the highlighted green, times, yeah, 0.1.1, but we want it in normalized form, so it's going to be times 2 to the power 0. I can just make this power superscript. All right, so that is the 0.1 part. Now let's work on the negative 4.73. Then I'm going to write it down here. So 0.4375. Let's assume it's a positive number so that it's easy for us to do. And at the end, we'll do any conversion we need to do, right? So the number is 0.4375. If to convert it, we know that 0, the binary for 0 is just 0. So the 0.4375, what we need to do is multiply it by 2. The answer we get is 0.875, which means that we get to keep the 0 as part of our binary. Now we're going to take everything at the right side of the point, which is going to be 0.875. 0.875, we multiply it by 2, which is going to give us 1.75. Now we get to keep this part of our math as part of our binary. We're going to do 0.75 times 2, which gives us 1.5. So we get to keep the 1 part as part of our binary. Now we're going to do 0.5 times 2, which gives us 1.0. And we get to keep this part as part of our binary. And because we hit a 0.0, we know we are done with this math that we're doing. So basically, the answer to the conversion of 0.4375 to binary is going to be 0, this 0, right? Point everything in yellow from top to bottom. So 0, 1, 1, 1. And we need it in what's the name? We need it in normalized form. So we're going to have to move this point 2 times. So 1, 2. So I'm going to put it here so I can delete this one. So it's 1.1. And because we moved it 2 times, it's going to be times 2 because we moved it 2 times. Negative 2, 2 to the power negative 2. All right, so, but it's a negative number. So I'm going to put my negative number in front of it so that everybody gets what's going on, right? Cool. So I'm going to remove the intermediates from it so that we know exactly what we're doing. So basically, negative 0.475 binary, no, binary is this one, and the normalized binary for 1.05, 1.5, right? 1.5 base 10 is this one. So we'll put it here so that we have. All right, so we're done with the conversion to binary. The next thing that they're saying is it says that add or subtract the unbiased exponents. So the unbiased exponents are 0 and 1. We're going to add them because it's the multiplication algorithm. So 0 plus negative 2, the answer is negative 2. So right now that we're done with this, we're just going to take the values without the exponents and without the times 2. And what are we supposed to do? We're supposed to multiply them. So we're just going to do our normal multiplication, which is going to be 1.1 times 1.11. And when you do this multiplication, you can decide to ignore the point, do all your multiplication. Whatever number you get, you count the number of decimal places that you need. In this case, we need 1, 2, 3. So we need 3 decimal places. So the answer I got was 10101. So if I start from the back, I'm going to do 1, 2, 3. I put my full stop here in my period. And this, we know, is supposed to be a negative number. So I'm going to put my negative in front of it, right? But mind you, as soon as we get this, we are going to add, we're going to make it as it should be, the normalized form. We dropped 2, this is going to be times 2 to the power negative 2, because when we added the unbiased exponents, we got negative 2. So it's going to be whatever we get times 2 to the power negative 2. Now we have this answer. We need to normalize this. So when you get here, it says normalize results and include sign, which is going to be negative 1.0101 times 2 to the power negative 1. Right. So we're going to do it here, 2 to the power negative 1. Now this is our normalized form. How do we, there's no overflow, as I said in my other video, because we are going to this class, we're not going to give you with an overflow. How do we represent this in the registers? We know it is a negative number, so the first bit is going to be 1. We are doing single precision. What is the overflow? No, what is the biased exponent? The biased exponent is whatever our unbiased exponent is plus 127. So it's negative 1 plus 127. So let me write it here. So it's going to be negative 1 plus 127. So after you put your your sign here, you're going to put the binary of of positive 126, which is the answer that we get from this subtraction, this addition. And our mantissa or our fraction is going to be everything after this point. So it's going to be 0101. And we're going to fill it with zeros until you get to the 23 bits. I really hope that you all understood this. Thank you.